Hey, what's going on? Welcome back. Patrick here from All Things Mathematics, and moving on to the next question on the test. We have to find this crazy limit here. The limit as x approaches 0 of the square root of 1 plus x minus the square root of 1 minus x in the numerator all over the square root of 1 plus 2x minus the square root of 1 minus 2x in the denominator. Now, this limit in particular, if you haven't noticed by now, hopefully you did, we're going to have to do rationalization to solve it, but this is going to be one of those limits where we actually have to do double rationalization, right? Because we got square roots roaming around in both the numerator and denominator. And I've gone through examples like this in the lecture videos, both examples where we have to rationalize once, and also like this one where we're going to have to rationalize twice, right? So make sure you watch those, go through all the different scenarios. What I recommend doing is pausing the videos at the beginning, try it yourself, then watch the video, see how your steps and your answer compares to mine. And so once you get to your actual test, you'll feel fully prepared for different scenarios that can come up. So with this one, we're going to have to rationalize both the numerator and denominator as mentioned. So let's do this one by one. I'll start with rationalizing the numerator first, right? So we're going to have to multiply this by its conjugate. Now, what's the conjugate going to be? Well, the expressions on the end are going to stay the same. Only this sign in the middle is going to change to a positive, right? So we're going to have the conjugate's going to be the root of 1 plus x plus the root of 1 minus x, like that, right? But we can't just multiply this limit by this random expression in the numerator. We have to also multiply it in the denominator, and then root 1 minus x, like that, right? So keeping this expression the same because it's like we're multiplying it by 1, just changing the format of it. However, by doing this, what's nice is that we can algebraically manipulate it a bit because we could get rid of these roots here. So the reason why we multiply by the conjugate is that this is going to be a difference of squares, these two brackets multiplied. It's like a minus b times a plus b, and that's going to be a squared minus b squared, right? So all we have to do is multiply these ends together, these ending terms together. The middle terms we don't have to worry about from foiling out because they're going to cancel. So root 1 plus x times root 1 plus x, that's going to give me 1 plus x, minus root 1 minus x times root 1 minus x, that's going to be 1 minus x. You want to keep that in brackets though, right? Because you're going to have to distribute that negative. You're subtracting that entire expression right there. Now the two expressions in the denominators, they don't relate at all, right? So we are going to have to keep them separated. So let me just write out that original expression. In the denominator, I'm just trying to be really careful. There's a lot going on here. Plus root 1 minus x, right? Like that. Just keeping those two expressions separated. And then what's the numerator going to simplify to? Well, notice that if we distribute the negative, the ones will cancel out, and then we'll have x minus negative x, which is like x plus x. So that is going to simplify to 2x. And so now the updated limit we have is this right here. Now notice that we still can't cancel out, right, any x's in the numerator and denominator. We have an x at the top here, but unfortunately in the denominator nothing yet can cancel out, and we need to in order to be able to plug in that x value of 0. I actually didn't mention, I forgot at the beginning, what's the first thing we always check with a limit? Can you do a direct substitution? And if you look at the original limit, if you plug in 0 for x, you would get that indeterminate form of 0 over 0. So I forgot to mention that. So what we're trying to do here, right, like all limits, is basically get it to a point where we could cancel stuff out, where then we can plug in that x value of 0. All right, so now we rationalize the numerator, which is fine. Now we have to rationalize this expression in the denominator, and the same process is going to apply. We're going to multiply that expression by its conjugate, right? So it's going to be the root. The n expressions are going to stay the same. And we're just going to change that sign in the middle to a plus. And then this is going to be 1 minus 2x. But again, can't just randomly multiply an expression in the denominator. We also have to multiply that same expression in the numerator in order to keep that limit the same, right? It's like we're multiplying it by 1. So now what's going to happen, the limit as x approaches 0, okay, the two expressions in the numerator multiplying, can't do anything with those, so I am going to keep them separated in brackets like that. But then, so let's be super careful here. So this and this are going to multiply, right? We're multiplying this by its conjugate. Again, it's going to be a difference of squares. So all we have to do is multiply the n's by each other. So root 1 plus 2x times root 1 plus 2x, that's 1 plus 2x, minus root 1 minus 2x, root 1 minus 2x, that's going to be 1 minus 2x, like that. Okay, and then this expression we keep as it is, root 1 plus x plus root 1 minus x, right? Like that. Okay, and so what's going to happen here, notice that if we distribute the negative inside the bracket, the 1's will cancel out, and then we'll have 2x minus negative 2x, which would be like 2x plus 2x, which would be 4x. So this entire thing right here is going to simplify to 4x. So our updated limit is going to be the limit as x approaches 0 of 2x. Keep all of this the same, root 1 plus 2x plus root 1 minus 2x. That's going to be all over 4x. That's what this bracket simplified to, root 1 plus x, and then plus root 1 minus x, like that. So that right there is going to be our updated limit. And notice what happens here. Well, at this point, the x's cancel out, which is what we wanted, right? So the x's cancel out and we have an updated limit. Now you can also simplify this 2 over 4 to 1 over 2. Let's just keep it for now. It's not too big of a deal. But what we can do now is we can sub in that x value of 0. And we're not going to have that indeterminate form anymore. So we're going to end up with 2 over here in this bracket. This would be like root 1 plus 2 times 0, which is 0, plus root 1 minus 2 times 0, which is 0, like that, all over 4 root 1 plus 0 plus root 1 minus 0. These are actually the same expressions, right? So this is going to end up being 2 times 4. This would end up being root 1 plus root 1, which is 2. Root 1 plus root 1, which is 2. Cancel, cancel, 2 over 4, 1 over 2. So that ends up being the final answer for this limit. Right, so pretty hectic one with the double rationalization. Lots going on. You got to be super careful with your algebra, especially with the signs, right? Mixing these up. The only sign that changes is in the middle, right? So yeah, answer is 1 over 2. As I mentioned, make sure you go back to the lecture videos, do the other tests as well on the site, practicing rationalization in different scenarios. Sometimes you'll do single rationalization. Maybe your teacher will want to take it to a next level and do double rationalization on a test. So make sure that you're prepared for both. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.